Hello, I'm John. I'm an undergraduate student in chemical engineering at the University of Birmingham, and I've been working alongside Glenn to use 3D printing in order to assist with the teaching in undergraduate labs. I'm going to walk you through a few of the experiments and show you how we've used 3D printing to solve some of the problems we've had. The first experiment that has been developed relates to measuring the flow through pipes. This is obviously important in the chemical industry. The idea behind the lab is to get students to think about the different ways to achieve this. 3D printing allows engineers to rapidly test their ideas and build prototypes. Printing a component to fit between sections of pipe allows different measurements to be taken. An example of this is a small joint, which measures the static pressure and velocity head. The second experiment aims to help students become more familiar with the use of and the process behind developing continuous static mixers. Normally, the fluids are liquid, but static mixers can also be used to mix gas streams, disperse gas into liquid, or blend immiscible liquids. The energy needed to mixing comes from a loss in pressure as fluids flow through the static mixer. Using a 3D printer means that students can draw and print off their own mixing designs of components and use the test rig to measure and analyse the breakup of water droplets and pressure drop. Scale-up of chemical processes, particularly those involving batch or semi-batch manufacture, is well known to be a problematic area of chemistry and chemical engineering, and it can be very costly when it goes wrong. The third experiment allows students to analyse the effect of scaling when mixing. They can design their own impellers, print them off at 2 different scales, and measure their power numbers. Following this, they can verify the standard scale-up strategies, benefits and drawbacks, and then predict how their design will perform on an industrial scale. The purpose of mixing impellers is to transfer the energy provided by the motor to the fluid in the most efficient way. Also called agitator blades, each mixing impeller type converts the energy slightly differently. The next experiment aims to show the effect different impeller shapes have on mixing time. Thermocouples are an easy way to indicate the uniformity of mixing throughout the fluid. Students can design and print their own impellers to test the mixing time and efficiency.